I'm Associate Professor for Food Process Engineering at the University of Nottingham. And I took on the position just about 3 years ago after a career in industry, in the food industry. Effectively, I'm course director for creating a new food process engineering program within the university. And while Nottingham has always excelled at food science, etc., the step into engineering is new on the food side, but of course it combines with I'm in the Faculty of Chemical and Environmental Engineering, and it's very symbiotic to the same. So I think that there are, well, it's interesting going forward. I think the key words, and I think that's come across from the entire seminar, is, you know, if you had to define two words there, one is change and the other one's innovation. And yeah, hopefully going forward, that's what we're about, University of Nottingham. And I think, you know, having spoken to yourself, Charles, I think that's what IAGRI is about. So I think it's combining forces to actually get the world back on the right footing again when it comes to food. How's the screen there? You can see it.
Yes.
Okay, well, to everybody, hi. And again, I agree. Thanks for the opportunity to present this. It wasn't quite intended, I think, for me to be the last speaker. But hopefully this presentation is really actually a summary of what all the other speakers are saying. You know, the whole thing, re-engineering the food industry, Quo Vadis. I mean, that's basically the English version of Quo Vadis. When we were doing the research for this paper, we discovered that not a lot of people younger than 35 done Latin in school. So, I mean, it's basically, where do we go from here? And you're looking at elements right across the food sector. You're looking at nutrition, water, raw materials. Indeed, all of the things that our existing speakers have spoken about. I mean, when it comes to food, or when it comes to man, yes, we're still evolving. They estimate we've been on the go for 2 million years. But if you think about it, every part of that evolution has always been about food. And as we go forward, or as we look forward, I suppose that's a problem in its own right as to where we're actually going to. But if you think about food from way back, food production has always defined our societies. Think of the hunter-gatherer, think of the agricultural society, where we actually started developing grain crops, etc. And more recently, the industrial societies, and of course the Industrial Revolution, which just now is terminated. But it has all created the industry that we know today. You know, if we talk about the first Industrial Revolution, that might have been steam, second Industrial Revolution, power, etc. And you had the buildup of all of these wonderful brands and big food, as it's now referred to. We also, on the engineering side, developed new preservation processes. And if you look at the time and the time that it has taken, you can see that these new development processes are coming at us much, much faster as we develop and evolve new technologies. The food industry itself, well, you know, you think back over the past 10, 20, 30 years, and if you think of it from an investment perspective, you would say, no, the best investment must have been computers, or no, the best investment had to be healthcare. And that's coming to the fore even more so now. But the actual best investment was the food industry. And to a degree, that has probably led us to where we are today. If you had have invested $1,000 in food industry stocks in 1963, that number would now be worth £1 million. Food industry has created the highest profitability of all industries. When you think about it, change is on the way. If you have a look at the top companies and have a look at where they're at currently, the big food companies are actually dropping in sales. If you think of it from a bell curve perspective, has that top of that bell started to turn? That's on the one hand. And you've got, on the innovation side, you've got small, medium companies, and they're actually seeing growths of 15%, and that's compounded per annum. So what's happening? What's happening in food manufacturing? It was Heraclitus 2005 years ago that, well, basically he summed it up in simple words. There's only one constant in life, and that's change. And I think that's what we're seeing in the food industry. And I think listening to some of our speakers earlier, that's also coming through loud and clear. Change is on the way, or as Heraclitus said a long time ago, the only thing that's constant is change. I mean, if you think of the end of the 20th century and the Industrial Revolution, that actually led the development of big food and big food manufacture. It came to an abrupt end at the turn of the century. And that was what we kind of realized, that the entire process, or the economic model that was the Industrial Revolution, just could not sustain basically the resources that are in nature. That was A. And then B, from a sustainability perspective, nature does not have an infinite capacity to absorb the world's waste. So it's change and changing the industry. Another element, maybe 40 years ago, when the US government came out with a proposal that we must eat less of something, and that was namely saturated fats and high cholesterol foods. It was adopted by Britain in 1983, and these guidelines, well, basically they shaped how food was manufactured, what the world ate. But it basically backfired when you look at some of the statistics that are coming across these days. And if we just look at the UK alone, obesity costs in the UK last year was 27 billion. It's higher than the police, fire service, and judicial system combined. By the by, the UK is probably the largest consumer of processed food. And again, that has evolved and developed over the past 30, 40 years. If we look at the global cost of our current model, it was figures that came out of the Ellen MacArthur Foundation a while back, referring primarily to the circular economy. But what they're saying is that for every plate of food that we put on the table today at a cost of $1, it's actually costing us $2 to produce it. And you don't have to be a mathematician, an accountant, or anybody else to figure out that that's just not simply sustainable. And we touched on it earlier, I think some of the speakers did, in terms of agricultural fertilizers, taking them out of the ground. We're looking at the cost of obesity and health problems. All of that is contributing to that $2 cost, which, as I said, is simply not sustainable. So if we're looking at the 21st century, relative to the last 200 years, where it was all about profit, today it's changing. You've got to incorporate the social element, and you've also got to incorporate the environmental element. Business is changing, making more with less, carbon credits and taxes, the information age, Google. I don't know how many in the audience are lucky enough to be under the age of 21. But think about it. Google 6 months ago only celebrated their 21st birthday. So things are happening. They're happening rapidly. And from a food processing perspective, yes, there are a number of key factors that are coming into being, but it's things like ethical sourcing, sustainability and traceability, and of course, innovation and consumer demands. And we'll come to that just now. But effectively, the food industry, as we know it, and as it's been performing over the past 30, 40 years, it has no alternative other than to change. When I joined the university 3 or 4 years ago, there were several different models out there. So I thought I need to come up with a model. And I looked at it from the food industry and from my own experience. And I thought, isn't it, if it comes back to nature, it effectively, it's the circle of life. If you think about, we go back to the agricultural age, where people grew grain and they milled that product between two stones. It was 2,000 years ago when the water mill was invented. And at the turn of the 18th century, the UK had roughly 20,000 water mills for milling grain. Steam changed it. And if you think about it, each time that new technology develops, it goes through that growth phase and actually replaces the previous industry. So if anything to gain from this model, it's quite simply that new development, new growth is actually going to put into maturity and or decline existing systems. We talked about change as change being a fundamental basis for the universe, if one likes it. What you've got to think about is the rate that that change is actually occurring now. You know, for centuries, human growth rate was basically linear. You look at it today and you look at where we're going to, and it's become exponential. Perhaps another way of looking on that was Gordon Moore. He was the co-founder of Intel. And in 1965, he projected, or he forecast that the number of transistors or the processing power of computers, well, particularly that could be squeezed onto a silicon chip, would double every 2 years. So again, you're looking at that exponential growth. And think about it, 1971, Texas launched their new little chip with 8,000 transistors. 2015, it was Oracle came out with 10 billion transistors. Think about it today. You're now looking at a 1 terabit chip that fits in the top of your finger. The growth has become actually exponential. How do we manage? How do we do that in the food industry? You know, how do we do that from a university? How do we put together courses or programs for educating future food specialists in 20 years with that exponential growth rate? To me, there's no other way of doing it. You've got to literally embrace that change. And yeah, this is Nottingham and how we're looking at it. If research is our answer, we're looking at developing future food going forward with a number of specific primary areas. And I'll cover one or two of them just now, but this is where we're looking at with that key question. How do you feed the world as population grows to 10 million? And while we're looking at research and development, one would think that from a food manufacturing perspective, it will be the same. Unfortunately, it's not. If you look at the companies globally, the top 10 companies, as you can see there, is a mixture of high tech, well, Amazon, Alphabet, Volkswagen, Samsung. Well, let's just have a quick look at Amazon. And whether you like the guy or whether you don't like the guy, look at the research that's going into future development. That's 12.72%, or a research spend of 22 billion. One would imagine, given the changes that we're going to encounter going forward, that the food industry will be up there at the top of the list. It's not. You've got to page right down. And as you can see, probably the top food, big food company is actually Nestle at position 77. But again, look at the research spend here. It's 2.35%. Things are changing, and I think attitudes are changing. And I think we can take Nestle here as an example. Let's hear from the CEO of Nestle.
Is a moment for us to reflect. We must focus on building a better future that addresses the huge challenges facing society today. Perhaps the biggest one of all is climate change. It will define the future for every family, community, and business on the planet. The economic recovery should deliver faster and more ambitious progress in climate change. Many companies, including Nestle, will do their part on the way towards net zero emissions. At Nestle, we will work towards this objective and deliver affordable, sustainable nutrition wherever we operate. I call on policymakers, companies, and others to build a recovery that protects health and the environment, accelerates progress on climate change, and delivers prosperity for all.
We mean business. It's a coalition of big companies, and that's the slogan: "Build Back Better." It's unfortunate with that video that somebody didn't hold the chap's script in front of him, so he wasn't looking to the left as he said it. But the key here is build back better. And how do we build back better, given circumstances that are out there, i.e., consumer lifestyles and the way they're changing? Let's have a look at some of the other forces that's driving that change. Okay, some of the ones that quickly went off the screen there: more working women, growth of older population, inverted commas, the graying of Europe. Interesting that we were talking about Africa. I mean, Africa has the youngest population, or the highest amount of people under the age of 25. But again, globally, you're looking at smaller households, you're looking at changing family structures, you're looking at the rise of lifestyle diseases, and more importantly, for the industry going forward, you look at mass scale urbanization. They estimate by 2050, 85 to 90% of people will live in cities. But people, younger generation, they're also looking for different things as we go forward. Consumer is changing. And I love this quote: if you don't like change, you're going to like irrelevance even less. Keeping it real. I'm looking for products and brands that have real, authentic, and honest origins. And currently, that's not where we're at in food or food production, food manufacturing. If you look at that a bit further, by way of Nielsen, with another survey, people, when it comes to food, they're looking for free from, and you can see it: artificial colors, flavors, etc. Clean, free from artificial ingredients. Again, is where over the years we've looked at chemical additions, etc. Is that the right thing going forward? Keeping it simple, recognizable ingredients, and more importantly, sustainable. You're looking at organic, you're looking at fair trade, and you're looking at humane, which all comes back to changing the industry. If we look at this graph on the right hand side there, where traditional big food, high consumer demand, and traditional purchase drivers, that's changing. When you look at what we've just even looked at now, those evolving drivers, it's creating that new normal. And that's coming about more because people are looking at the food industry from a different perspective. If you look at that green outline around the circle here, it's transparency. And where before we were looking at price, taste, and convenience, now it's also health and wellness, it's safety, it's social impact, and it's experience. And of course, people have full access with communications or modern communications as to where that goes. If we look at it from a bigger picture, if we think of the one Earth that we've got, we've only got 29% land. The rest of it's oceans. And if you look at that land, break it down further, only 71% of that is habitable land. 50% of that is into agriculture. But then when you look at how we divide that agricultural land and look at the calories that we're generating, then you think of livestock, you think of animals, etc. And then, of course, you've also got the whole side of carbon footprints, etc., etc. Again, we've got to think differently as we go forward with 10 to 10 billion people. Conventional food production, it's not only just running out of time, it's also running out of land resources. This is a lovely graph from the World Wildlife Federation. And what they're saying is, if we carry on our current path and retain the status quo, not only are we looking at killing a basic diversity in terms of the planet, but also in terms of diets, etc. If you look at the food loss, weight, how do we get to that point where we're getting back to nature, restoring it? If you think about carbon emissions, if we keep going the way we're going, it's projected that by the year 2100, that 5 degrees increase in temperature, it's basically going to destroy us. If we kind of regulate it to a little degree, and I mean, that was what Paris Accord was all about, we're still looking at a 3% increase. We've got to start looking at getting carbon emissions right down to ensure our survival going forward. So if we go back to that graph or to this template that we talked about earlier, food production defining our societies, we've got to think differently. We've got to look at creating a new food revolution that's actually going to change the way we currently operate. Just for thought, with the advent of sustainable power, and we're talking about wind generation, we're talking about photovoltaic cells, we're looking at heat. There's a whole load of different new sustainable ways of generating energy other than the using of fossil fuels. UK are saying by 2030, they will actually have that to the point where 40 gig of our current requirements will be generated by sustainable means. That's energy. What if we could actually look to produce food from air? And some of our earlier speakers actually touched on it with the use of microbes, etc. I'm going to stay quiet for about 6 or 7 minutes now, and I'm going to introduce you to Professor Lisa Dyson, who's going to give you an overview on a possibility.
Imagine you are part of a crew of astronauts traveling to Mars or some distant planet. The travel time could take a year or even longer. The space on board and the resources would be limited. So you and the crew would have to figure out how to produce food with minimal inputs. What if you could bring with you just a few packets of seeds and grow crops in a matter of hours? And what if those crops would then make more seeds, enabling you to feed the entire crew with just those few packets of seeds for the duration of the trip? Well, the scientists at NASA actually figured out a way to do this. What they came up was actually quite interesting, and it involved microorganisms, which are single-celled organisms. And they also use hydrogen from water. The types of microbes that they used were called hydrogenotrophs. And with these hydrogenotrophs, you could create a virtuous carbon cycle that would sustain life on board a spacecraft. Astronauts would breathe out carbon dioxide. That carbon dioxide would then be captured by the microbes and converted into a nutritious carbon-rich crop. The astronauts would then eat that carbon-rich crop and exhale the carbon out in the form of carbon dioxide, which would then be captured by the microbes to create a nutritious crop, which then would be exhaled in the form of carbon dioxide by the astronauts. So in this way, a closed-loop carbon cycle is created. So why is this important? We need carbon to survive as humans, and we get our carbon from food. On a long space journey, you simply wouldn't be able to pick up any carbon along the way, so you'd have to figure out how to recycle it on board. This is a clever solution, right? But the thing is, that research didn't really go anywhere. We haven't yet gone to Mars. We haven't yet gone to another planet. And this was actually done in the 60s and 70s. So a colleague of mine, Dr. John Reed, and I, we were interested actually in carbon recycling here on Earth. We wanted to come up with technical solutions to address climate change. And we discovered this research by reading some papers published in the 60s, 1967, and later articles about this work. And we thought it was a really good idea. And so we said, well, Earth is actually like a spaceship. We have limited space and limited resources. And on Earth, we really do need to figure out how to recycle our carbon better. So we had the idea, can we take some of these NASA-type ideas and apply them to our carbon problem here on Earth? Could we cultivate these NASA-type microbes in order to make valuable products here on Earth? And we started a company to do it. And in that company, we actually discovered that these hydrogenotrophs, which I will actually call nature's supercharged carbon, overlooked and understudied, and that they could make some really valuable products. And so we began cultivating these products, these microbes in our lab. We found that we can make essential amino acids from carbon dioxide using these microbes. And we even made a protein-rich meal that has an amino acid profile that's similar to what you might find in some animal proteins. And we began cultivating them even further, and we found that we could make oil. And oils are used to manufacture many products. We made an oil that was similar to a citrus oil, which can be used for flavoring and for fragrances, but it also can be used as a biodegradable cleaner or even as a jet fuel. And we made an oil that's similar to palm oil. And palm oil is used to manufacture a wide range of consumer and industrial goods. So we began working with manufacturers to scale up this technology, and we're currently working with them to bring some of these products to market. We believe that this type of technology can indeed help us profitably recycle carbon dioxide into valuable products, something that's beneficial for the planet, but also beneficial for business. But that's what we're doing today. But tomorrow, this type of technology and using these types of microbes actually could help us do something for even greater if we take it to the next level. So we believe that this type of technology can actually help us address an issue with agriculture and allow us to create a type of agriculture that's sustainable, that will allow us to scale to meet the demands of tomorrow. And why might we need a sustainable agriculture? Well, actually, it is estimated that the population will reach about 10 billion by 2050. And we're projecting that we will need to increase food production by 70%. In addition, we'll need many more resources and raw materials to make consumer goods and industrial goods. So how will we scale to meet that demand? Well, modern agriculture simply cannot sustainably scale to meet that demand. And there are a number of reasons why. And one of them is that modern agriculture is one of the largest emitters of greenhouse gases. In fact, it emits more greenhouse gases than our cars, our trucks, our planes, and our trains combined. Another reason is that modern ag simply takes up a whole lot of land. We have cleared 19.4 million square miles for crops and for livestock. What does that look like? Well, that's roughly the size of South America and Africa combined. And let me give you a specific example. In Indonesia, an amount of virgin rainforest was cleared totaling the size of approximately Ireland between 2000 and 2012. Just think of all of the species, the diversity that was removed in the process, whether plant life, insects, or animal life. And a natural carbon sink was also removed. And so let me make this real for you. This clearing happened primarily to make room for palm plantations. And as I mentioned before, palm oil is used to manufacture many products. In fact, it is estimated that over 50% of consumer products are manufactured using palm oil. And that includes things like ice cream, cookies. It includes cooking oils. It also includes detergents, lotions, soaps. So you and I both probably have numerous items in our kitchens and our bathrooms that were manufactured using palm oil. So you and I are direct beneficiaries of removed rainforests. So modern ag has some problems, and we need solutions if we want to scale sustainably. So I believe that microbes can be a part of the answer, and specifically these supercharged carbon recyclers. These supercharged carbon recyclers, like plants, serve as the natural recyclers in their ecosystems where they thrive. And they thrive in exotic places on Earth like hydrothermal vents and hot springs. And in those ecosystems, they take carbon and they recycle it into the nutrients needed for those ecosystems. And they're rich in nutrients such as oils and proteins, minerals, and carbohydrates. And actually, microbes are already an integral part of our everyday lives. So if you enjoy a glass of Pinot Noir on a Friday night after a long, hard work week, then you are enjoying a product of microbes. If you enjoy a beer from your local microbrewery, a product of microbes, or bread, or cheese, or yogurt, these are all products of microbes. But the beauty and the power associated with these supercharged carbon recyclers lies in the fact that they can actually produce in a matter of hours versus months. So that means we can make crops much faster than we're making them today. They grow in the dark, so they can grow in any season and in any geography and any location. And they can grow in containers that require minimal space. And we can get to a type of vertical agriculture instead of our traditional horizontal agriculture that requires so much land. We can scale vertically and as a result produce much more product per area. If we implement this type of approach and use these carbon recyclers, then we wouldn't have to remove any more rainforest to make the food that in the goods that we consume. Because at a large scale, you can actually make 10,000 times more output per land area than you could, for instance, if you used soybeans, if you planted soybeans on that same area of land over a period of a year. 10,000 times over a period of a year. So this is what I mean by a new type of agriculture. And this is what I mean by developing a system that allows us to sustainably scale to meet the demands of 10 billion. And what will be the products of this new type of agriculture? Well, we've already made a protein meal. So you can imagine something similar to a soybean meal, or even corn meal or wheat flour. We've already made oils. So you can imagine something similar to coconut oil or olive oil or soybean oil. So this type of crop can actually produce the nutrients that would give us pasta and bread, cakes, nutritional items of many sorts. And furthermore, since oil is actually used to manufacture multiple other goods, industrial products and consumer products, you can imagine being able to make detergents, soaps, lotions, etc., using these types of crops. So not only are we running out of space, but if we continue to operate under the status quo with modern agriculture, we run the risk of robbing our progeny of a beautiful planet. But it doesn't have to be this way. We can imagine a future of abundance. Let us create systems that keep planet Earth, our spaceship, not only from not crashing, but let us also develop systems and ways of living that will be beneficial to the lives of ourselves and the 10 billion that will be on this planet by 2050. Thank you very much.
Let us develop new systems. It's an interesting hypothesis, isn't it? You know, what Lisa Dyson was referring to was hydrogenotropes, which is basically a single cell organism that goes back, scientists estimate, 3.5 billion years. One of the first life sources that ever happened on our planet. But if you look at that schematic on the right-hand side and look at their inputs relative to their outputs, basically, they're looking at carbon dioxide, they're looking at hydrogen, and in turn, they're able to produce a highly nutritious, high protein product. It's not a replacement, no, but it's an interesting alternative as to how we go forward and how we adopt modern ag, and as a result, food production and food systems to actually make that change that is basically the essence of the universe. If you think about it, you know, if that power to isolate the hydrogen from water could be done by sustainable resources such as wind power, etc., then basically you end up with food from air. Hydrogenotropes grow exponentially. They will double themselves every half hour. They don't need light. They don't need anything other than carbon dioxide. But think of the way we could actually produce food from it. It's one of the reasons that we've actually looked at it in our School of Chemical and Environmental Engineering. And we've basically got our MSc students working as part of an accelerated design training program to actually develop a process, manufacturing process, using these single cell organisms and producing a high protein quality flour. It was an article on the BBC last year, and they were, what's actually happening with this particular process is it's been developed by a company in Finland from one of the universities, but it's now actually coming on stream next year. And I know there's developments going ahead in America with it. But as I said here, it's why we have 70 of our current MSc process engineering students working in 12 design teams to complete the same project design brief. I think going forward, that's the key. We have to change the way we're doing things, not just from an agricultural perspective or not from a food perspective, but given the drive for cost savings or money profitability over the past 50 years, how do we make that change to a diet-driven, health-valued, knowledge food system without engineers? And that's the key. You know, all of our food processing, going back over millennia, has been developed and designed by food engineers in different guises. Financial management on its own is not going to change things. We need to look at this technology. We need to look at inventing new ways and new systems of operation. And the only way we're going to be able to do that is with the right engineering skills and the right engineering knowledge. You know, if you look at it from a consumer perspective, with cell phones, etc., they're going to look after themselves. And hopefully, with that knowledge and with that development, I mean, they say, well, in parts of Japan, etc., you already have it. You have your own personal avatar on your cell phone who's telling you what your ideal weight should be, what the ideal food should be, etc., etc., etc. And they will drive change in the industry. But again, how does the industry make that change without the engineering skills to do that? It's one of the reasons University of Nottingham has actually developed their MSc program in food process engineering. But if you look at it at a wider scale, you think of food development, food manufacturing, food processing, and you think, wow, it's kind of a low-skilled labor force. That's not the case. In the UK alone, we've got 440,000 people working in food manufacturing. And if you look at that percentage at the top, roughly 8.4% of them are highly skilled people requiring a postgraduate degree or a PhD. Take it as a rough number, take it as 10%. 10% of 440,000 people is actually 44,000. And what we're seeing in industry as we go forward with that change, the lack of engineering skills in the industry is now becoming increasingly problematic. 3% of food production is so-called big food. The other 97% is being run by so-called SMEs. Now, when we talk about an SME, you think of a small company, but they can be in the turnover range of 200 to 500 million. And if you look at that graph on the right-hand, or you look at that bar chart on the right-hand side, 50% of those people are saying it's difficult to find food engineers. The other 50% are saying it's extremely difficult. How do we make that change? How do we expand our knowledge base? How do we increase the interest in food process engineering? Well, a simple one is the fact that and I'm wearing the hat of a male engineer, but 50% of our population is female. The world needs more creators. An interesting point. We're saying the world needs more engineers, and particularly when it comes to food and food process engineering. Let's just have okay, I'm probably running out of time a little bit here, nearly finished. Let's just have a look at some of our international students currently studying food process engineering. Oh, sorry about that. That was me.
We started out 2 years ago to develop a new MSc program in food process engineering. My expertise is from the engineering, originally electrical engineering, and 35 years of the food industry.
So it's one of the basic desires of human beings, and it's very cool to work with that. And the other thing is, what I did in chemical engineering set a very firm base of my studying food process engineering.
I studied food process while I was in China. So after I come to Nottingham, some of my knowledge I can use to my courses now.
Nottingham is not only providing me with the technical knowledge required to walk into any job in the food process engineering industry, it's providing me with the soft skills such as communication, teamwork, and organisation.
Nottingham has lots to offer you, and there are many different projects, different industry visits, which help you to become a better food engineer.
I think the possibilities and the potential for food process engineering going forward is absolutely amazing.
I think the mega food companies all are global companies, so being an international graduate is helpful to get the better spectrum of the industry.
Outside of studies, the Students' Union offers lots of opportunities to take part in activities or volunteering to really create a rounded experience of your year.
If you're interested in a career in food process engineering, particularly a master's degree and above, then have a look at our website, have a look at the specific pages related to this.
Yeah, okay. Just a taste of it. When it comes to understanding food, Nottingham has been around for over 50 years. In fact, in terms of food development, food research, we're #1 in the UK. And we've always looked at the development from farm to fork. But going forward, we need to look at it also from an engineering perspective. And while food has been recognized as one of 6 pillars of excellence with a 200 million commitment to future research, and we're looking at developing that and evolving it in partnership. In fact, I'll chat to some of our colleagues from Africa later on, but the world needs change. The world needs to develop that change, and the world needs to develop the technology for that to happen. As I said, engineering to me is the answer. And that's Nottingham. I believe other universities around the world need to look at developing food process engineers or the competence, probably not just on the engineering side, but also the science side, understanding food process engineering theory, being able to communicate, being able to convince the accountants that are now running the businesses that they need to change, and we need the new technology to do that. I'm not going to go into too much details on the course overview, and I hope I provided you with some ideas, some concepts on a couple of points. One, change, it has to happen. 2, innovation, it is happening. And as that slogan said, you know, if you don't like change, you're going to like irrelevance even less. So for a future going forward, food industry, food processing, we basically need more food process engineers. And on that note, thank you very much.